exercise 21.2, question 4. So there's a particle projected at a height of h at an angle here of theta with a speed of u. So let's call the unknown distance here, which the question wants us to find, as x. And then you also have to find the time t. So we think we're going to use the Suvat equation that we have been using for all of this, that r equals r0 plus ut plus a half a t squared. And we start thinking what r, r0, u, and a are. Well, we know if we take the origin as being here, then r0, our initial position, is going to be 0 h. And we also know then our final position, r, is going to be x and 0. And we want to find that x. What else do we know? Well, we know that the initial velocity, u, as a vector, is the scalar u times by cos theta, and then the scalar u times by sine theta. V we don't actually care about, because we're not going to use that in that equation we wrote down. A we are actually given in the question, but we know A is going to be 0 and minus g, because the only force acting is gravity. So we start putting that in to our Suvat equation. We're going to get r, which is x 0, equals r0, which was 0 h, plus ut, which was t, and then u cos theta, and then u sine theta, plus a half times a, which was 0 minus g, t squared. Well, each line of this, because the horizontal and vertical components are independent, gives us an equation in t. So if we take the horizontal components, you have therefore got x equals ut cos theta, and you also have 0 equals h plus ut sine theta minus g over 2t squared. And the question wants us to find t and also to find x. So actually, if you look at that second equation is a quadratic equation in t. We can solve for t in terms of h, u, and theta. So we go ahead and do that. I'm probably just going to do that using the quadratic formula. We have a equals minus g over 2, b equals u sine theta, and c equals h. So putting that into the quadratic formula, we have t equals minus u sine theta plus or minus the square root of b squared, which is u squared sine squared theta, minus 4 ac, which is actually going to be, we multiply that by minus g over 2, so that's going to be plus g over 2, 4 times g over 2, which is 2g, so 2gh, all over 2a, which is all over minus g over 2 times 2, which is over g. So that is our value of t. One of those is going to be positive, one of those is going to be negative. If we look, actually, we're dividing by negative g, so actually we want the numerator to be as large as possible. So the t that we're interested in is going to be t equals minus u sine theta minus the square root of that thing, divided by minus g, or actually divided by negative 1, you get t equals u sine theta plus the square root of u squared sine squared theta plus 2gh all over g. And that's our value of t. We're now asked to find x. Well, if we go back to our equations further up, we get x equals ut cos theta. So all we need to do is multiply that t that we've just found by u cos theta. So that gives us x equals, well, u times u, so u squared, sine theta cos theta, so sine theta cos theta. Well, the next thing is going to multiply by u cos theta, so that's going to be plus u cos theta times by the square root of u squared sine squared theta plus 2gh, and then all of that divided by g. I can't quite fit that in here, but we just know that x is equal to u cos theta all times by the value of t that you've just found. Check that right.